in Toronto. And she's also appointed as an assistant professor status in the Dalla Lana, I can never say that right, the Dalla Lana School of Public Health, and as a visiting scholar at Massey College, which is an interdisciplinary graduate college at the University of Toronto. Now, the reason that I'm so delighted in introducing her is that Victoria is a graduate of the Occupational Hygiene program here and has since completed her PhD at the University of Toronto with a focus on occupational skin and respiratory health. Those of you in my class and you looked at the Arrandale paper, this is the Arrandale. Okay. Victoria's current research focuses on developing an exposure database for the Ontario mining industry and examining the risk of chronic respiratory disease and lung cancer in a retrospective cohort of Ontario miners, and particular focus on the employment mobility of workers and mixed occupational exposures. Victoria's current research is supported by a Career Development Award in Prevention from the Canadian Cancer Society Research Institute and the Ontario Ministry of Labour. And with that, I turn it over to Victoria.
Okay, thank you very much for the introduction, Karen. I'm really happy to be back here. And I'm going to talk a little bit about some work that was done at the University of Alberta in 2012, 2013, and it was part of my postdoctoral fellowship done under Nicola Cherry at U of A. So I would like to take this time to just recognize the co-authors on this paper, Jeremy Beach, George Simbrowski, and Nicola Cherry. It'll be coming out in the annals shortly, so if you listen carefully, you don't have to read the paper later. So what this work that I'm going to talk about today is really some early results from a really exciting prospective cohort study that's underway at the University of Alberta. And it was a sub-study that looked at urinary metal concentrations among a group of female welders based in Alberta. So women are actually increasingly pursuing careers in the trades, even though they're traditionally male-dominated. Lots of reasons for this. In Alberta, the oil and gas industry supports a lot of jobs in trades. They're also quite financially lucrative for people, so they offer a good source of income. And over the years, women's participation in trades has increased quite dramatically. So the graph that's shown here has time in years on the x-axis and women as a percentage of certifications, and this is welding only in this graph. And we can see that from 1990 to 2010, the percentage of women certifications in welding in Alberta has increased sort of 5- or 6-fold over time. So there's still quite a small proportion of the workers that are working in welding, but their participation is increasing. And so that's sort of where some of the impetus for interest in this area has come from. So a reminder about the basics of welding for people who aren't familiar or want a little bit of a refresher. So we've got a schematic here at the top. And there's lots of different types of welding, and we'll talk a little bit about the different types later. But generally what you're doing is joining two pieces of metal together, and you're using energy to do it, usually electrical. Sometimes it's a flame. But you have an electrode that brings the charge or the energy, and you melt the metals together within the arc. And in some cases, the electrode is consumable, meaning that it gets used up as the welds are laid down. And in other cases, it's not. There's a wire that comes in from the side. There's also shielding gases that aren't shown in here that clear the area that you're welding to ensure a clean surface for laying down the weld. And on the bottom, there's a photo of welding in action. And you can see that there's a lot of smoke and dust coming off, and that the worker is actually wearing quite a bit of personal protective equipment. They've got gloves and a smock on, and they've also got the welding mask, which protects them from the UV light coming off the weld, but also allows them to see what they're actually doing. So there's a lot going on when people are welding. And we know that there's a lot of hazards and a lot of health effects that are associated with being a welder. So we talked just a little bit there about the welding fumes, the small particulate that is generated. metal dusts come off. Often welders finish the welds after they've laid them down to ensure the surface is, looks good and is smooth. There's ultrafine particles generated during the welding process and the shielding gases that I mentioned, and UV radiation, as well as things like heat and noise. Often these welders are working in environments where there's lots of other things going on around them, so the noise is not necessarily coming from the welding activity per se. And there's also ergonomic hazards that these workers are facing. They are often not just sitting at a station welding the same thing over and over again. If they're welding a pipe or they're welding a tank, they're often having to position themselves in very strange positions in order to weld exactly where they need to weld. And this variety of health hazards can result in a lot of things. And historically, the most common has been the metal fume fever that's been associated with welding. But there's also things like manganism, which is sort of a Parkinsonism type disease from high manganese exposure. Work-related asthma does seem to be more common among welders, as does chronic obstructive pulmonary disease and dermatitis from handling of allergens, allergy-causing metals, or irritant dermatitis from wet work and hand washing. And ocular melanoma results from the UV exposure. And so welding is in fact classified as a group 1 carcinogen by IR based on the association between welding and ocular melanoma. Yeah. Okay. And so what do we know about welding and women's health? And so as you can imagine, based on the graph at the beginning, that women are really a small portion of the population of welders. And most of the studies are focused almost exclusively on men. And there are a couple of exceptions to this. But in the cases of the exceptions, they haven't stratified their results by sex. So it's actually not clear whether there are sex differences between the men and the women. And there's another paper that looks at female welders in jewelry manufacturing, which is slightly different than the exposure circumstances that we were interested in. So there's not a lot of evidence about women's health in welding, but there is a lot of concern. So the Welding Safety Committee of the Canadian Standards Association in the early 2000s expressed quite a bit of concern about the impact that welding may have on women. A lot of women entering this trade are in their 20s, 30s, they're in their childbearing years, and they're trying or want to become pregnant. And so there was a lot of question around whether it was safe for them to remain in this workplace while they were in that phase of their life. But from the research side, and this is where the group at the University of Alberta came in, there was a lot of questions of feasibility and whether it was going to be possible to get enough women welders to ask these questions and get meaningful results. And secondarily, what the impact of the results would be on women who were working in the trade. So there was hesitation about pursuing these research questions initially, because really we don't want to ask these questions and exclude women from the workplace. We want to make sure that the workplace is safe for anyone who wants to pursue a career in the trades and in welding specifically. There is a little bit of information about welding and reproductive health. So in terms of men, which is the predominant group in this occupation, there's some inconsistent evidence around semen quality and impaired fertility. Bond et al. Have shown both findings, one showing that they do have reduced semen quality, the other not. And then a study from India showed that sperm concentration and sperm motility were negatively associated specifically with chromium and nickel levels. So there's a suggestion that there is some association with reproductive health in men who are welders. And there is actually studies that have looked at reproductive health among women. There's a British study, Farrow et al., that found low birth weight babies were more common among women who were working in jobs that involved metal forming or welding, so more diverse. And a Finnish study that found premature births were associated with metal fume or dust exposure, and low weight babies associated with welding fume or metal dust. And then Sweden, so still in Scandinavia, they found preterm births were more common in women who were employed in welding, but this elevation wasn't significant. So these studies are all population studies. They have asked for self-reported information on occupation. They haven't done any quantitative exposure assessment. And they've also compared these women to the general population. And some of the concerns there is whether that is a reasonable comparison group for women working in the trades. There's a lot of discussion as to whether the healthy worker effect may come into play, whether the women working as welders are in fact quite different from women working office jobs and things like that. So these are some evidence, but we're not convinced really with the evidence we have here. And so this led to the development of the WHAT-ME study. And WHAT-ME stands for Women's Health and Apprenticeship Trades, Metalworkers and Electricians. And WHAT-ME is a prospective cohort of women that are working in either welding or electrical trades. So the electricians here are a comparison group. The primary aim of WHAT-ME is to investigate the effect of welding fume exposure on reproductive health. So that's the overall study goal. And what happens is anyone who registers in an apprenticeship training program in Canada is registered with a provincial apprenticeship body. So there is a list somewhere of everyone who starts an apprenticeship and everyone who finishes an apprenticeship. And so all women that were registered since 2005 have been sent a letter by their provincial apprenticeship body inviting them to participate in this study. And those letters went out to anyone that was registered in a welding trade, so a little bit broader than welding specifically, but anybody registered in welding, boiler making, steam fitting, or pipe fitting. So these are all trades that do quite a lot of welding in their daily tasks. And then electricians, again, recruited as the comparison group. And this does include both residential and industrial electricians. So it is also a diverse group unto itself. They began recruiting in Alberta, and they have now included participants from all Canadian provinces and territories. So this has been quite an undertaking from an administrative standpoint, but everyone is really quite excited about the possibility and is really on board. So now, I believe it's every year, but periodically the board, the apprenticeship bodies do send out a new wave of letters to anyone that we haven't heard back from to try and encourage them. They're also using social media to reach out to women who may have not received their letter, and using the women that have enrolled in the study to reach out within their networks of women working in the trades to try and encourage them to join in. And one of the real strengths, I think, of this project is that they are able to complete their questionnaires and things, as we'll see down the road, but online. So these women can call in or they can complete the questionnaires online, because we know they're quite mobile and a lot of them are working outside of the cities. They're not often in the city, or if they are, it's like a frantic few days where they're trying to get all their stuff done before they go back to work. So the original goal for WHAT-ME was to enroll 400 women welders and also 400 electricians from across the country, and that's gone very well. They're almost at their targets, and in fact on target to reach the 400 by the end of this year. And these women will be followed up for up to 5 years for a variety of health outcomes, including reproductive health. So what happens once someone agrees to participate in WHAT-ME? The subjects complete a baseline questionnaire, and at the baseline questionnaire, they're asked for a complete job history. So any work that they've done in the trades or outside of the trades, everything is recorded, and they've also asked for a full reproductive history around any previous pregnancies and the outcomes of those pregnancies. And then from that point forward, every 6 months, the participants are recontacted, and at that point, they complete a detailed exposure questionnaire, and that's asking about their work since the last questionnaire. If a pregnancy occurs, the women immediately notify the study coordinator of the pregnancy. They have a pregnancy postcard essentially that they mail back, and everyone has one. And they mail the pregnancy postcard back, and then they collect a urine sample as quickly as possible, and they do complete 2 questionnaires during the pregnancy and a 3rd questionnaire following the completion of the pregnancy to follow up on the outcome, so to speak. And the group at U of A had done some previous pilot work in Alberta to validate both the exposure questionnaire, so they had direct observation and then exposure questionnaire responses to validate and then they also did validate the mail-in procedure for the urine. So you have to remember that these women are spread out all across Canada, and we can't analyze their urine in each province or even in each city. So the urine is collected at home by the study subjects. They're mailed a kit that with detailed instructions and a collection vial, and then it literally gets sealed up and mailed back to the university where it's analyzed. So this procedure was also validated, and they found that the time delay in processing does not affect the concentration that is detected. So that has been done previously. So the questionnaire, which happens every 6 months, collects information on about the last day that the individual worked in their trade. And we get pretty detailed information on their welding tasks, both whether they did them or not and how long they did them for, including what type of welding it was, what base metals they were welding, what rods and wires, flux, whether they were using shielding gas or not, and what coatings may have been on the metals that they were dealing with. We also get really detailed information on their use of PPE and ventilation, and both of these questions are asked task specific. So it's not a broad question, it's a when you did this task, were you using PPE or was your local exhaust ventilation in operation? We also have asked about the time that they spend indoors and outdoors, because we know, particularly in Alberta in oil and gas, that a lot of them are working outdoors a lot of the time, and their time spent in confined space. So we have a lot of information on one day at work, and the idea here was that one average day taken every 6 months over 5 years would give some idea of a complete picture of what their typical exposures were like when they were working. What I'm going to focus on today actually is a very small fraction of this, and perhaps you'll see why when we get later on. But I'm going to talk mostly today about welding tasks, and I'm going to present on the yes-no aspect of the task rather than the duration, though it doesn't change the results very much. So my piece in this massive cohort study was a sub-study of biomarkers in these women. And so at the beginning of the study, subjects who recruited from Alberta, which is where the study started, were asked to provide a urine sample at the time of the 6-month follow-up. So this was a non-pregnant urine sample. Everybody in Alberta was asked to mail in a urine sample following the same procedures as the pregnant urine sample. So they collect it at home, they seal it up, and they put it in the mail to be sent back to the university in Edmonton. And you can see at the bottom the timeline of how this was planned out. So the baseline questionnaire was completed at time 0. As we approach the 6-month follow-up, they're sent a reminder as well as the request to mail in their urine sample. And so ideally what happens is that the urine sample is collected the same time that the 6-month questionnaire is completed, and the questionnaire is asking about the last day that they worked in their trade. So we'll talk more about this later, but this is really how we had hoped that the samples would be collected. So the main objectives of the biomarker sub-study were to answer these sort of 3 questions. Are urinary metals higher in female welders than in women in the general population? Are urinary metals higher in female welders than in male welders? And which work practices are associated with urinary metal concentrations in our group of female welders? Once we received the urine samples at the university, the samples were analyzed at the university hospital, which is the main clinical lab for the province. So they're quite experienced in this. They participate in all sorts of quality control programs. They quantified 14 metals for us using ICP-MS. I'm going to report here on 7 of them today, and that's purely for practicality reasons. These are metals that we think are important for welding, but they're also metals that we could find comparison values either for the general population or for male welders. So actually one of the big challenges was finding information to compare to. Our data analysis, we did have values below the limit of quantitation. I'll show you those, not a huge number, but we did use a substitution method. We used beta substitution, which gives you a substitution value based on your detectable value. So the number can differ depending on the sample that you're working with. We creatinine corrected these because they're spot urine samples. We don't have 24-hour urines on these people. They did one urine sample that could have been done first thing in the morning, at lunch. We didn't really know anything about the time it was collected. And we did transform the urine concentrations because it improved the normality of the data. Both the creatinine correction and the transformation are not consistent in the literature, but we felt that this was the best way to approach it. And we did do a few different things statistically with the urine concentration data. We did basic descriptives. We did do a principal components analysis, and I'm going to present that today. It's a way to take our 7 metals of interest and find out if we can summarize them in a fewer number of variables. And we did multiple linear regression models where we used the component scores from the principal components analysis as our outcome variable. And then we also did it again using individual metal concentrations as the outcome variable. And our predictor of interest here was the different welding types. And we included smoking and age where they were significant, and that was actually only in the case of cadmium, but we looked at it for all of them. For our comparisons with the literature, we used a selected 95th percentile, and we also looked at our geometric mean, median, and range. And I'm going to focus on the geometric mean when we get there. So our sub-study population, if you remember, our target for the welders was 400 welders across the country. Most of them are in Alberta. And to be included in this analysis, subjects had to have done work in their field or in their trade in the last 6 months. So we had 103 women who provided a spot urine sample at 6 months. Only 56 of these had completed welding tasks since the baseline. So if you remember, they could have been registered as an apprentice at any point since 2005, and they got the letter and people signed up. But not all of these women were actively working in their trade. And because we were interested in welding exposures and urinary metal concentrations, we limited it to people who we knew had been working in their trade in the previous 6 months. Of these 56, 9 had concentrations that were outside the acceptable range for creatinine. So they were either too concentrated or too dilute. And so these are limits that are set by WHO and accepted by the ACGIH. So we did exclude 9 more subjects, and we excluded 2 additional who actually weren't in welding trades and somehow had snuck under the wire. So the results that we are going to present are based on 45 women welders who had worked in their trade between baseline and 6 months. So we've gone from 400 to 45. So we're talking about a smaller number, I think, than we had hoped when we set out to do this. So again, here's the schematic that I showed earlier, but the urine collection time in relation to the questionnaire completion, as well as the last day work, varied quite considerably. It wasn't recorded in all cases, which was the first challenge, but where it was recorded, the time between completing the questionnaire and collecting the urine sample averaged 22 days. So they were quite far apart in reality. One of the problems with this number is it is inflated. So what happened was at first people weren't recording the date very well, and the people who took longer to return their sample had more reminders to record the date. So we do think that the 22 days is much longer than the true mean, but that's the only mean we can report because we don't have data from everyone. So our population, like I said, it's 45 female welders, averaging about 27 years old. We had quite a range, though, if you see there, 17 to 52 years of age. The women going into these trades are often going in as a second or third career. So they're not all young, but they do tend to be younger. About a third with current smoking. There's another third or so that are former smokers. So there's quite a lot of smoking history, which is important for some of the metals. And at 5% or so, we're actively trying to conceive at the point at baseline. That's where these are from, sorry. And importantly, not for the sub-study, but there were no significant differences between welders and electricians at baseline. And so that's an important fact when we think of the study as a whole, but we're going to focus on welders with this analysis. I thought I'd put this up just for interest, really. These are the characteristics of the last day work. So you can see at the top that these women are actually working long shifts. So that's the mean shift length of the last day worked being 9.5 hours. So they are working long shifts, but seemingly not working a lot after midnight. So less than 5% reporting sort of an overnight shift on their last day at work. And if we look further down, their use of PPE, or at least their reported use of PPE, is very high. So they're all reporting using gloves and using protective clothing, mechanical ventilation across the board, and quite a high proportion reporting that they did use their local exhaust ventilation for any task that they did that day. So it limits our ability to ask questions about some of these variables, but I thought it was quite encouraging that they were sort of using the equipment that was there for them. And so when we have analyzed the samples and we get them back from the lab, these are our 7 metals. The first column here is our limit of quantitation from the lab. The next one is our numbers of samples below the limit of quantitation, and this is an N, not a percentage. So we had a few metals, manganese and zinc, with all samples being detectable. Our highest proportion less than the limit of quantitation was nickel, where we had about 1/3 of the samples. So not a huge problem here, but as I said, we did do the beta substitution to deal with this. And if we look over to the left, we have all our descriptive statistics, and I thought I would just point out this top line is cadmium, and the highest value we had recorded in this group is 0.93 micrograms per gram creatinine. And the ACGIH biological exposure index is 5. So these women are not approaching the exposure limit set out in the BEIs. So we just wanted to point that out. There is a BEI for chromium and cobalt, but it's not in creatinine, or not creatinine corrected. It's an end of week measure in micrograms per liter, so it's not directly comparable to this data. But our women don't get near that for those metals either. So what did they do on their last day at work? They do lots of different things. So at the top are tasks related to welding. So 1/3 of them are pipe welding. 2/3 are doing fabrication and a variety of other tasks. The bottom half of this graph shows the welding type, and that's really what we're going to focus on in terms of the urinary metal concentrations. So the most common type of welding was the shielded metal arc welding, or stick welding. The next most common was the gas metal arc welding, and this is also known as metal inert gas, or MIG welding. And then the tungsten arc welding, or TIG, is the other name that it goes by. So those were our 3 most common. We didn't have anyone reporting plasma arc, and only a few reporting submerged arc or other kinds. And the other could include things like oxyacetylene welding, which uses a flame and things like that. So mostly focused in the top 3. But what was surprising to me, and maybe shouldn't have been, is that 1/3 of them reported doing more than one kind of welding on their last day at work. So they were doing a variety of different things, which in a way complicates it just a little. But it was interesting to me that they were flipping back and forth. And they also had a variety in the types of metals and things that they were working with, although I'm not going to show that. So we looked at how the types of welding that they did were related to their urinary metal concentration. So these results are the multiple linear regression model. So each line is a single model, so that the coefficients here are adjusted for all different kinds of welding that the person had done on their last day. So it's not a single variable. They're each their own individual yes/no variable. And cadmium is the only model that we included age in smoking, because that's the only place where it was significant. And you can see from here, I bolded the one coefficient that was significant. So welders that were doing MIG welding had lower levels of cadmium. And we didn't see any other significant associations with the types of welding that they had done on their last day. So that was maybe a little disappointing. And so we then looked at how the metals were related to each other. And so we looked at correlation coefficients. These are Pearson correlation coefficients for all the metals. And we see that there are a few significant associations, but not drastically high correlations between these metals. The highest is 0.58 between cobalt and nickel, and really the rest fall below that. But we used, as I said, the principal components analysis to look at whether groups of these metals could be used to better identify exposure patterns. So the model that was supported in the principal components had 3 components, and I'll try to sort of briefly, you can create a component score for each person by weighting the urinary metal concentrations by the loading factors in the bottom half. But what we can see is that all the metals are positively loading or positively contributing to the component score for component 1. And in component 2, there's a contrast. So cobalt and manganese are negatively impacting that component score. So the contrast between cobalt and manganese with zinc, which positively contributes to that component score. So it allows us to look at how all of the metals can contribute to a single score, and then we can use that score instead of the urinary metals individually. So then that's what we did next. We looked at whether the component scores were associated with the types of welding that these women were doing. And again, we didn't have any associations here with smoking and age, but we also didn't see any significant associations between these composite scores with the types of welding that was happening. And I can tell you that we did look at other things like base metals that they were using, and we still didn't see, there was no clear patterns that were jumping out in this small group of women. So we shifted a little bit at this point to look at just whether the levels in the 45 women were any different than what we would have expected. So we compared first with the general population, and I'll walk through this slowly. What we wanted to do was find a 95th percentile for the general population. But this is not the easiest thing to find, so we had to use multiple sources. So the reference population shown on the left, number 1 is the Canadian Health Measures Survey. So this is data for Canadian women aged 20 to 39. The values under number 2 are from NHANES data in the US, also for women only. And 3 is NHANES data, but it combines men and women. So what we did is if we had a Canadian value for women, we used that as our 95th percentile for comparison purposes. If we didn't have a Canadian value, we then tried to use an American value for women. And if we didn't have that, we defaulted to just using an American value that was combined for men and women. And so that's what the 4th column shows here is the population 95th percentile that we chose. So to be very clear, we did choose this, and then we compared the proportion of the women in our sample that exceeded the 95th percentile. So we would expect, if the distributions are similar, that we would have about 5% of the women exceeding this 95th percentile. And what you can see immediately is that for chromium and manganese, we had large numbers of women that exceeded this. And for manganese, almost all of the women exceeded the 95th percentile. So this tells us that it looks like, for chromium and manganese at least, this group of women had very high levels, and the other metals are actually looked at whether these women had higher levels if we compare them to male welders. So we would a priori expect that they would probably have higher metal levels than women in the general population, but perhaps not necessarily so if we were to compare them with male welders. And we did compare these women's levels, their median, their geometric mean, and their range. And I'm just going to show you the geometric mean here. So the column with women is the 45 women welders in Alberta. Men 3 is Dutch stainless steel workers. Men 4 is some Russian welders, and men 5 is American Boilermakers. So quite a diverse set of groups for comparison, to be honest. And if we go down and we make the comparison across, the copper value for the geometric mean for copper is almost 4 times higher, or 3 times higher, pardon me, than the American Boilermakers. And the manganese, again, is seemingly quite high, twice at the highest, so 2 times higher than the American sample. The nickel level is the one that does appear to be lower than the male welders, but we're not, this holds when you look at the other measures, so the median and the range as well. So it looked for the comparisons with men that the copper and the manganese are higher and that the nickel might be lower. But again, we're comparing two very diverse populations. So some of the considerations that came out of this, we see the higher levels of chromium and manganese when we compare to the general population females. Higher levels of manganese continue to be observed when we compare to male welders. And what we sort of found when we dug into this is that there's an inverse relationship between manganese uptake and iron status. And we don't have iron status on these women. That's one of the metals that wasn't measured at the lab. But we do know that women are more likely to be anemic, and it's related to blood loss during menstruation. So the manganese observation really needs a bit more, I think, investigation. There's a potential biological explanation for that finding when we compare to the men. But we still saw the higher levels of manganese when we compared to the general population women, who presumably would have the same proportion of anemia. So our conclusions, to go back to the very beginning, are urinary metals higher in female welders than the general population? Well, these results would suggest that chromium and manganese seem to be higher in these women than in the average woman. Are urinary metals higher in female welders than in male welders? The results suggest that manganese and copper might be higher, but that nickel might be lower. And the other ones are chromium, cadmium, cobalt, and zinc. We didn't see any differences, or we didn't see any suggested differences in the comparisons that we did. And which work practices were associated with these metal concentrations? And really, these results were not as clear as we expected or we had hoped. The only association was between MIG welding and chromium. And there are many possible explanations for these null findings. One is the task variety, so they were doing multiple things on their last day work, and perhaps we're unable to classify their exposure correctly simply by the type of welding that they were doing. The sample size is the other problem, because we can't really classify their exposure much beyond that without running into sample size issues with 45 women. And the third problem or challenge was the timing of the sample collection. So we knew that the urine sample had not been collected in that window of exposure that we were really the most interested in. And we couldn't know that until we got the data. And so this is a little bit more information on that. This is not from the 45. This is from a much larger sample of the urine sample. So this was just to give you a feel for how much, in fact, it did vary. So if we were hoping to have the urine sample collected on the same day as the questionnaire, we only had 1% that did that, and then about 20% within the preceding 3 days, and it goes back. And if you look in the other direction, we actually had people, because they received the reminder to collect the urine sample and the reminder to complete the questionnaire at the same time. Some people collected the urine sample before the day at work, before they completed the questionnaire. So the order was not consistent. And so this was a real learning lesson for us. I mean, the study is ambitious. And goes across the country, so you're not able to stand over someone while they do this. So we'll get to how we're going to fix that. But there are many outstanding questions. One is, would the results be consistent if Canadian men and women were compared who are both working in the welding trades? And I think that's an important one, particularly in Alberta, where oil and gas dominates. They're doing slightly different things. So we want to be able to compare like with like if we can. And what factors might give rise to these differences if in fact they are real? And so there's a lot of questions around men and women and whether they have different levels of exposure at work. whether they're doing different tasks. So the women anecdotally report that they're responsible for doing more of the TIG welding, which is a finer task. It's a more careful thing that needs to be done, whereas the men are more often doing things like the stick welding, which requires a little bit more strength to do. So there's a possibility they're actually doing different things at work, and they may be doing the same tasks differently, which is a more qualitative question, but it's still an important question. And the final one is the biology piece, is whether these metals are being absorbed and metabolized differently in men and women, even at similar levels of external exposure. And so where do we go from here? Obviously, these results weren't as clear as we'd like them to be, but we still think they're important. We think this is the first time we've been able to look at biomarkers of metal exposure in women welders. It's a really unique population. But what has happened since is that the group at U of A is developing a cohort of Canadian male welders and electricians. So this is a group that would be much more directly comparable to the What Me cohort. This one's called What Men. The funding right now limits them to recruitment only in Alberta, but they've got almost 400 men, and they only started recruiting earlier this year, so they've really had no challenge getting people engaged and interested in this study. And we are planning a larger urine study, which will look at both men and women from Alberta at the same point in time. And the protocol has been refined to more explicitly tell the participants when we want the urine sample in relation to their last day worked and things like that. So there, I don't have the exact wording, but it does ask them to collect it at the end of a work week on the same day that they complete the questionnaire. And that was sort of the key piece that we had missed the first time round. So the next steps in the long term is that there's going to be two very large prospective cohorts of Canadian trades, so 800 women and 800 men. And there will be a really detailed investigation of the reproductive outcomes in women welders as compared to the electricians. And it'll be done on two levels. One is the fertility outcomes that are self-reported. And this is important because you can't get fertility outcomes that period of time if a woman is attempting to get pregnant and not having success. There's no other way to get that other than to ask people. So they have very detailed information on this, and that will be, I think, a big contribution. They also have consent from almost all of the subjects. The response rate was over 90% of those enrolling agreed to link their records with the administrative health records in each of their respective provinces. So they'll be able to look at the perinatal data to confirm the self-reported data and also look at associations with trade. And they'll also do a very detailed analysis of work-related health outcomes. There's a series of questions about work-related asthma, stress, dermatitis. So they'll have a lot of information. They can also pull on the administrative records for that as well. And in this case, they'll be able to do two comparisons. One is female welders to electricians, but also between women welders and male welders. So they'll have a lot of questions to answer and a lot of work still to do. And so with that, I think I'll leave it and take any questions that people might have.
Okay, if we could take some questions. And I'm going to remind anybody who has a question, not only do we need to use the microphone, we actually need to talk into the microphone in order for it to be recorded. So, questions?
Yes, Victoria, did you get data on the manganese content or chromium content or other metals content of what these women were working with on their last day at work?
Not explicitly, no, but we have, like I said, we have the base metal and we have the electrode and the wire, and we ask for the number. So what we have done is compiled a list of those, and we looked to the MSDS forms and things like that to identify. But it wasn't consistently reported. So some people gave us lots of information on what they were using, but not everybody gave us that. So there's a chance to look more into that, but not easily.
Hi, Victoria. How long does metal hang around in urine? I mean, I'm wondering, obviously you wanted to get the urine sample and the questionnaire on the same day. How much did that dilute your results?
varies really considerably. So if you look at the biological half-lives for the metals, both the proportion excreted in urine varies by metal, and the time frame in which it's excreted varies by metal. They all have some portion excreted in urine. Manganese is probably the most tenuous. It's quite low. But that relationship differs by the metal.
Hi, good job. That was very interesting. Just to elaborate a little bit more on that, and so ideally you wanted urine samples collected on the same day as the questionnaire. Did you notice any significant difference in concentrations between those collected, let's say, from 1 to 3 days of the questionnaire and those greater than 14 days?
The short answer is I'm not sure. I think that what I had looked at, rather than that period, was the period of time. So that range is a very logistic question. But what is actually maybe the more important question is the time period between when the urine was collected and the last day they actually worked. And when I looked at that, I didn't see any association between that delay and the concentrations that we observed. But I actually don't think I looked at the other period. Yeah.
So I know you already explained like why you chose the last day, but how did you come up with that idea? Because it's pretty interesting.
I can't take credit for that, actually. That's Igor Bernstein's development when he was at the University of Alberta. And so it was this idea that, you know, the snapshot over time gives you multiple repeated snapshots and would be more reliable to ask about a recent day at work than to get someone to recall what they've been doing over months or years. So yeah, it's an interesting, it is an interesting question, and it'll help. I think it is more relevant to the outcomes of the larger study than it was to this particular analysis, where we wanted to look at cross-sectional information. It's going back to the biomarker question, because there are different windows of exposure that we were really interested in for this. Whereas on the overall study, they want to get a feel for someone's typical exposure over their working time.
I was wondering, have people done studies of these metal concentrations in blood or hair or other samples from the body?
Absolutely, and they are better media for doing biomarker studies of metals. But when you have people distributed in different places and you're relying on the mail, so you can mail urine, you can't mail blood, and there's no way to collect it efficiently across. So the urine was selected from a practicality standpoint, not because it is the best biomarker medium.
My question is about your study population. You're eventually going to look at reproductive outcomes in female welders. So why not exclude women, female welders, who are not interested in getting pregnant?
They are interested, I mean, that is the primary question. There's a lot of other questions that they're interested in around work-related health in association with welding. It's a challenging, you get a very select population, I think, and this, I don't know why. So I wasn't there when this study was started. I should disclose that. And maybe if anyone from U of A is online, they can type the answer here. But I do think that if you enrolled only women who actively wanted to become pregnant, you may get a biased sample. So by getting all women in the trade, you get women who maybe are trying and maybe are not, and maybe have no interest in having children. But these things don't always happen in a planned way. And so this was the best way to get an unbiased sample of the population. And it also facilitates a lot of other interesting questions that can be asked that we don't have answers to either.
I have a question.
Yeah.
So you've got the data of the women who signed up for the apprentice program and completed the apprentice program. Can you tell us more about that actual cohort? Like how many women stay in the program on a population base?
We don't have that information. So that was one of the privacy limitations of going through the apprenticeship bodies. They sent the letters on our behalf. So we don't know. Even when they do the follow-up mail-outs, we give them a list of who we have heard from. That's all we can give them. And then they take those names off their mailing list and send to everyone else. So they would not share that information for privacy reasons. So they are the holders.
I just want to express our online audience sentiment that this is a very interesting topic study, and I think your talk is very interesting. So I have a question. Did you look at dietary sources of manganese? Because there are whole grains and nuts and seeds that have manganese. Not sure if the female welders ate enough of that to cause the elevated levels.
Yeah, we didn't, and we haven't asked any questions about that on the questionnaire. Lots of the metals have dietary sources. Zinc is another one that has a lot of dietary sources. So the short answer is no. The follow-up statement would be we would really have to be sure that as a group, this group would have very different dietary patterns than the electricians or the men working in the same trade. I think you could probably make a case that they have different dietary patterns than the general population for a variety of reasons. But whether it varies with exposure, I don't know.
Yeah, that's the thing with biomonitoring studies. Yeah. There is an online question from Nicole. Although the chromium levels were elevated, did the levels pose health risk? Also, was it determined what type of chromium, since chromium-6 is a possible carcinogen?
So they are elevated, and as I pointed out, they don't come anywhere near reaching the BEI set out by ACGIH. So no, they're not hazardous levels that we're seeing. And in response to the species, I don't know what species. I believe it's chromium generally and not chromium-6 specifically. But I could follow up on that. Yeah, I don't know.
I mean, it's just sort of follow-up to my earlier question, because my concern is if you include women that are not trying to get pregnant, and when you get the results, you classify them as not being able to get pregnant. Does that not dilute the result?
No, because at every 6 months at that questionnaire, they are asked whether they are trying to get pregnant. So it's very clear within the 400 or 800, depending on which group you're looking at. It's clear which people are actively trying and which people are not. And in fact, it's also clear we are asking about their sexual behavior in the sense of whether they're sleeping with men. So is there even a possibility of getting pregnant? So we can, it's a very detailed questionnaire that was tested in depth to make sure that the questions were not offensive or off-putting in any way. But yeah, we do have all that contextual information around their reproductive.
Did you see any difference in the work tasks being performed by female welders or in their adoption rates for PPE use that might explain any of the differences, or are they basically the same as men in that regard?
Well, we don't have the data on men yet. But the adoption rates for PPE were just very high across the board on the tasks that they were performing. And so no, we don't see anything within the women. It may be possible that when we have the information on the men that we see very different patterns of behavior.
Okay, any more questions? Hearing none, then I would like to thank you very much for coming back and presenting to your alma mater.